going to look at the Edexcel FP2 question on algebra based on series question from June 2011, question 4. In this question we've given an identity for 2r plus 1 cubed. We've got to find the values of the constants a, b, c. Then we've got to show that another identity is true for 2 marks, and using this result from part B and the method of differences, we've got to show that the sum of r squared from r equals 1 to n is a 6 of n plus 1 to n plus 1. The initial part of this question just involves taking 2r plus 1 cubed and expanding it carefully, either by doing a 3-bracket expansion, doing 2 brackets first and then afterwards doing a 3rd bracket expansion, or we can use a binomial expansion. I can use Pascal's triangle here to get the correct coefficients. So I need 1, 3, 3, 1. That's the line of Pascal's triangle I'm going to use. So it's going to be 1, 2r cubed, 3, 2r squared, another 3 times 2r plus the 1 at the end. So 2r plus 1 cubed is the same as 8r cubed plus 12r squared plus 6r plus 1. In other words, a equals 8, constant b is 12, constant c is 6. The mark scheme for this part of the question offers a method mark for expanding the bracket or using binomial expansion, and an accuracy mark for getting all 3 values correct. In this part of the question we need to prove this identity is true, and to do that I'm going to start off with the left hand side and show that the left hand side can be simplified right down to the right hand side. 2r plus 1 cubed we have already worked out is 8r cubed plus 12r squared plus 6r plus 1 minus, and now I need to do an expansion of 2r minus 1 cubed, again using the 1, 3, 3, 1 from Pascal's triangle. So it will be 1, 2r cubed plus 3, 2r squared times the minus 1 plus 3, 2r minus 1 squared, and then finally 1 lot of minus 1 cubed. So we've got 8r cubed plus 12r squared. This one will be 8r cubed, and because this bracket contained a minus 1, the signs will alternate now. So the next term will be minus 12r squared, and there's a minus 1 squared here, so this goes back to being plus 6r, and minus 1 cubed is minus 1. So we've shown that this can now be tidied up. If you collect like terms, I'll write it without the brackets so to make it clearer. Watch out for double negatives. So we've got minus 8r cubed minus minus 12r squared minus 6r minus minus 1, and we collect like terms and get 24r squared plus 2, which is of course the right hand side. The mark scheme for this question gives a method mark for for expanding the brackets, and an accuracy mark for the final answer. Notice that final answer was a given answer, so you need a correct solution only for this. Okay, so we need to have a completely clear, complete method in order to get the accuracy mark at the end. So in this part of the question, we need to use the identity found in part B and the method of differences. So if we look at this summation that we're looking for and we use the answer from part B, I can now turn this, using part B, I can write the sum of 24r squared plus 2 from r equals 1 to n has got to be the same as the sum of 2r1 plus 1 cubed from r equals 1 to n minus the sum of 2r minus 1 cubed from r equals 1 to n. So that's using the identity from part B and doing a summation from 1 to n. Now if we look at the summation on the right hand side, I can now put in r equals 1, r equals 2 into these summations to see what happens. So when I use r equals 1, so the first one I'm going to do is r equals 1. I'll get a 3 cubed from this one, and the second summation will give me a 1 cubed. And then when I go on to do r equals 2, I'll get a 5 cubed minus a 3 cubed. I'll just do one more at the top end. Let's do r equals 3. I'll get a 7 cubed minus a 5 cubed. And if we look at the last 2 or 3 terms, I'm going to get a plus 2n minus 3 cubed minus 2n minus 5 cubed. So that happens when r equals n minus 2. Then I'm going to let r equal n minus 1, and that'll give me 2n minus 1 cubed minus 2n minus 3 cubed, and lastly the last term when r equals n, I'll get 2n plus 1 cubed minus 2n minus 1 cubed. Now if we look at all these terms that we're adding up, you get what's called diagonal cancelling. So these are going to cancel, so will these, and these, and these, and the one above that one will cancel as well. So will the 7 cubed. And the only terms we're left with will be this term in the top corner and this term in the bottom corner. So this summation is going to be 2n plus 1 cubed minus 1 cubed, and that will be the sum of 24r squared plus 2 from r equals 1 to n. So now we can start to look at the summation on the left. So now, instead of doing the sum of 24r cubed plus 2, I can split this up as the sum of 24r cubed from r equals 1 to n plus the sum of 2 from r equals 1 to n. And I can expand 2n plus 1 cubed. We expanded in part A, So now that's going to be 8 n cubed plus 12 n squared plus 6n plus 1. So that's 2n plus 1 cubed from part A. The sum of 24r cubed, every term in that series will have 24 as a common factor, so I can write it as 24 the sum of r. It's supposed to be an r squared. Apologies, let me just quickly fix that. It's the sum of r squared. Sorry about that typing error. From 1 to n plus. This is an interesting series. We're now doing, every time r goes up by 1, we still have the value 2. So this series is going to go 2 plus 2 plus 2 plus 2 plus 2, and it will do that n times. So 2 plus 2 plus 2 plus 2, n times, the series would add up to 2 times n. So now we can find 24 times the sum of r squared, taking 2n away from both sides. And then we can divide through by the 24. I'm going to take 4n out as a common factor. So we'll have 4n times 2n squared plus 3n plus 1 all over 24, and therefore the sum of r squared from 1 to n is the 4 will cancel out with the 24 to leave us 6, and the quadratic will factorise to give n plus 1, 2n plus 1, and that is the summation for r squared. The mark scheme for this part of the question awards a method mark for clear use of the method of differences and an accuracy mark for correctly identifying the remaining terms after the diagonal cancelling. The remaining marks for this part of the question, there's a method mark for dealing with the left hand side, so I correctly breaking up the left hand side. There is a B1 mark for correctly identifying the sum of 2 from 1 to n is going to be 2n, and there is a final accuracy mark, but again the answer's given, so you will only get that mark if there's a complete solution only. That's the only way you can get that mark, if the previous solution is absolutely accurate. There are further resources available at the Further Mathematics Support Programme website, which is www.furthermathematics.org.uk.